This is our second lesson on functions, and what I'd like to do here is I'd like to talk to you about function notation and generally kind of getting more into the weeds about how a function works. So what I want to start with here is I want to introduce to you the idea of the rule of a function. To be honest with you, I don't particularly like this terminology, the rule, but I haven't found anything better, so I'm sticking with it for now. So, for example, this function takes its inputs and multiplies them by 2. Okay, so that's an awful lot of writing. Let's go back to our goofy picture, right? So in our goofy picture, we have that little machine. The machine has a name. In the previous video, I called the machine Acme because I wanted to elicit the Roadrunner and Coyote memories for some of you maybe. But what this function does is it takes an input and multiplies it by 2. So, I don't know, like for example, if you fed it 7, what's going to come out of it? Well, say it with me, 14. All right, at the risk of spending way too much time drawing these goofy pictures, and you'll notice that eventually we get sick of it and we start drawing sort of an abbreviated version of them. If you feed it -5, what comes out? -10, right? So any input you feed it, you get 2 times that coming out. Well, rather than doing another example with a number, what if we just say, let's call the input something non-committal. Let's say that the input is x. What comes out? Like, what happens to x after the function has acted on it? Well, the function takes its inputs and multiplies them by 2. So if x went in, try to say it with me, 2 times x came out. So now, what if I wanted to have a way to express this more quickly? What if I didn't want to have to write all these words? The function takes its inputs and multiplies them by 2. And thinking ahead, what if the function is more complex? What if it doesn't just multiply its inputs by 2? What if it multiplies them by 2, then subtracts 7, and then divides the result by 3, right? Like, what if it's an involved function and we don't want to have to write everything out? It would be good to have some symbolic notation, a shorthand of sorts, that said the same thing. So what we're going to do now is we're going to say, you know what, let's give the function a name that's not Acme. We can call it anything, but for our purposes at the beginning, we're just going to give it the most boring name ever. We're going to call the function f. You'll notice that the tradition is to write f sort of cursive. You don't have to, but that's sort of the tradition, is the names of things get sort of fancy font. And so rather than saying rather than writing out the words, if you put 7 in as the input, 14 comes out as the output, what we would say here is just that the result of f having acted on 7 is 14. What we would say here is the result of f having acted on -5 is -10. And what we would say here is the result of f having acted on x is 2x. So let's take a little moment to have like a bit of notation clarity. So if we have this written down, okay, so I'm just taking what I wrote here next to our 714 example and copying it there. The way that we would say this is f of 7 is 14, okay? So what we're doing here, and I want to stress this so much, is we're just introducing a shorthand. So now let's go into a little bit more detail. So I'll actually write a definition. F of x, so there's f parentheses x, and this is pronounced f of x, not f times x or f parentheses x, is the output that the function that the function f assigns to the input x. Okay, so to use my super goofy picture that you guys are definitely not sick of yet, right? If we have our function named f, and we put x in as the input, f of x is what comes out as the output. By that same token, if we use kind of the blobs idea, all right, so again, just for the sake of convention, let's put inputs on the left blob and outputs in the right blob. Okay, then x could be an input, f of x is an output, and the function f assigns x to f of x. Okay, so that again brings us back to this idea that the most important thing when it comes to functions is this idea of inputs and outputs. So let's look at an example. In this example, we're really going to dissect the concept of rule a little bit further, and we're going to do some examples in terms of evaluating a function and kind of working with it. So say that we have the function f of x is equal to x squared minus 7. So imagine that we didn't have this beautiful shorthand yet, this beautiful function notation. Imagine you had to write in words what this function does to its inputs in order to produce an output. So what happens to x to turn it into x squared minus 7? This function squares its inputs then subtracts 7. Okay. Now, let's ask some questions. Okay. So question 1. What is f of 4? Okay. Well, let's look here at our definition, and then we'll draw pictures. It'll be great. F of x is the output the function f assigns to the input x. So what I'm asking you here is, and again, here I go with that picture. I'm sure you all love it, and if you don't love it, you probably should learn to love it because we're going to draw it a lot. So we have our function f, and we're dropping in the input. So here, the input is 4. I've been making my inputs purple, so let's do that. And what I'm asking you is what comes out? Well, in this example, f of x is x squared minus 7. So this function squares its inputs, then subtracts 7. So you tell me, what is going to come out when we square 4 and subtract 7? Let's write that out. 4 squared is 16, minus 7 is 9. So you could actually write here, f of 4 is 9. Okay, let's do another one. So, what is f of negative 3? Okay, so again, going back to our definition here, f of x is the output the function f assigns to the input x. So here our input is negative 3. So I'm going to draw the picture again. All right, here we are. Oops. I think you all can tell I'm ready to move on from drawing the whole picture. But here's our function f. Negative 3 comes in. What will come out? Well, if you square the negative 3, what do you get? You get positive 9. And then you subtract 7. Well, negative 3 squared is 9, minus 7 is 2. So what we see here is that f of negative 3 is 2. So once again, I very much hope that what you're gathering in this lesson is that with functions, probably the single most important thing when you're talking about a function, dealing with a function, is asking, how does the whole input-output relationship work? What are the inputs? What are the outputs? So I'm going to ask you one last question, and this question is going to be really framing an important distinction. So, for what value of x is f of x equal to 2? So look what I did there. In the previous two examples, I asked you, hey, what's f of 4? I asked you, what's what's f of negative 3? So I'm giving you the input, and I'm asking you, what happens when this function acts on this input? What comes out? Whereas here, I'm giving you the output. I told you what came out. And I'm asking you, what must have gone in? All right, so let's draw the picture. And you might actually think that in this particular instance, the picture is not super helpful, but I think it's pretty helpful, so we're going to draw it anyway. So what I'm telling you here is that the output was 2. Notice I'm writing it a little bit off to the side because I want you to remember something. That if you put some input x in, what this function puts out is x squared minus 7. So x went in, x squared minus 7 came out, and that happened to be 2. So another way of asking the question that we have here in example C is, for what value of x would x squared minus 7 be 2? Now, some of you might be looking at example B and thinking, doesn't she see f of negative 3 was 2? And you're absolutely right. B did part of the work in C for us. But we shouldn't get too carried away, because as you maybe remember in our first lesson on functions, there may be two different inputs that correspond to the same output. So there may very well be another value of x. So let's see ourselves through. So what we're doing here is we're solving this for x. Okay. So I hope that your homework 1 practices have helped you here. So you could either subtract 2 from both sides and factor, or you could add 7 to both sides, and you get x squared is equal to 9. And now here's my question, and answer it with me. Pause the video for a second if you need to. Whose square is 9? What would you square and get 9? 3 or negative 3? So x can be 3 or negative 3. In other words, if you give this function the input 3, or you give this function the input negative 3, you are going to get 2 back as your output in both cases. So this concludes our mini lesson on function notation. In our next video, I'll actually do a couple more examples on function notation just so that you get more comfortable. But I think you'll see it's going to be a pretty short lesson, the next one, and I think very quickly you'll start to grab onto it. The key, again, with functions remains. You are always talking about input-output correspondences. Everything about functions is about inputs to outputs. So if you really frame all of the questions about functions around inputs and outputs, I think you'll see that your understanding starts to develop very well. All right, that's the end of this video. See you soon. Bye.